Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we learned questions related with exercise number 2.5, which exercise number 2.5 has completed. In today's video, I am going to start a new exercise number 2.6. So let's move toward question number 6 of exercise number 2.6. It tells that use any suitable rule of differentiation to perform d by dx or dy by dx for the following function. Part A tells in question number 1. Y is equal to under root of 1 minus cos x divided by 1 plus cos x. Find the derivative of this function. We cannot find the derivative of this type of function directly. First, move towards solution. I am going first to rationalize the given function inside the radicand. So 1 minus cos x. Here the conjugate of 1 plus cos x is 1 minus cos x. So we multiply and divide 1 minus cos x. So it becomes 1 minus cos x and 1 minus cos x. And here we have 1 plus cos x. So it becomes under root of 1 minus cos x divided by 1 plus cos x, and its conjugate is 1 minus cos x and 1 minus cos x. So it becomes y is equal to 1 minus cos x whole square. So it becomes 1 minus cos x whole square in the numerator. In denominator, we use the formula a plus b into a minus b gives us 1 minus cos square x. So according to a square minus b square formula. So it becomes y is equal to 1 minus cos of x divided by 1 minus cos square x is actually equal to sin square x and can be written as sin x whole square. So here we take 1 minus cos x whole square and divided by 1 minus cos square x is actually equal to sin square x and can be written as sin x whole square. So I write sin x whole square and under the root. Now squares cancelled with under root, we are left with y is equal to 1 minus cos x divided by sin x. So we can write it 1 over sin x minus cos x divided by sin time of x. Now after this I am going to take out 1 over sin x common. So 1 over sin x common inside we are left with just 1, and here if we take out 1 over sin x common, we are left with 1 minus cos of x. Now we have a formula of half angle identities. We will learn inshallah it in the chapter number 10 and 11. Cos of 2x is actually equal to 1 minus 2 sin square x. So by simplification it becomes cos of 2x minus 1 is equal to minus 2 sin square x. It becomes 1 minus cos of 2x is equal to 2 sin square x. Here we are going to take the value of 1 minus cos x. So 1 minus cos x will be actually equal to 2 sin square x by 2. So putting the value, so it becomes y is equal to 1 over the value of sin x. Sin 2x is 2 sin x cos x, sin 2x by 2 times 2 sin x by 2 cos x by 2. So the value of sin x is 2 sin x by 2 cos x by 2. So put here 2 sin x by 2 and cos of x divided by 2. And the numerator we are left with 1 minus cos x, which is 2 sin square x by 2. So can be written as 2 sin x by 2 and x sin x by 2. Now what are this sin x by 2 and 2 is cancelled with 2 and sin x by 2. So we are left with y is equal to sin x by 2 cos x by 2. It gives us tangent x by 2. Now we know that the derivative of tangent x is secant square x. So here taking the derivative of both sides, so dy by dx will be equal to the derivative of tangent x by 2. So put replace x with tangent x by 2, so it becomes tangent x by 2 is equal to secant square x by 2. So its derivative will be secant square x by 2. But here we have inner function x by 2, so its derivative will be 1 over 2. So this is the required answer, that dy by dx is actually equal to 1 over 2 secant square x by 2. Now move to part number B. It tells that y is equal to cos time of x plus pi by 2. Find their derivative. We have a formula that cos into x plus theta will always be equal to, this is let's suppose first angle and let's suppose this is second angle. So cos will take the first angle x and also take the second angle. After this the work of sign is this, that cos changes the sign. Here it is plus, so after this the sign will be changes and both of the angle x and theta will be taken by sin x using the same formula over here. So it becomes y is equal to cos will take first x and after this cos will take pi by 2. So it becomes cos pi by 2. Now here the sign is plus, so according to the formula the sign will becomes minus, and after this both of the angle will take by sin. So it becomes sin x and sin phi by 2. Now after this you know that y will be equal to cos of x. Pi by 2 gives us angle 90. So it becomes cos of 90 degree minus sin x and pi by 2 gives us 90 degree, so it becomes sin 90 degree. You know that cos of 90 degree is equal to 0 and sin 90 degree is equal to 1. Putting these values, so it becomes y is equal to cos of x multiply cos of 90 is 0, so put 0 minus sin x and you know that sin 90 is equal to 1. So this whole term will be equal to 0. We are left with y is equal to minus sin x. And you know that derivative of sin x is always equal to cos of x. So taking the derivative, it becomes dy by dx will be equal to minus time of derivative of sin x is cos x. So this is the required derivative and the required result for the part number B. Now move toward the part number C. It tells that a function is given y is equal to sin time of sin x. So this is the inner function. So move towards the solution for the part number C. Let's suppose this inner function which is sin x. So let's suppose this sin x is actually equal to t. I suppose it taken as a t, so it becomes y will be equal to sin time of let's suppose this function sin x is actually t. Now after this I am taking the derivative of both sides with respect to x. So dy by dx will be equal to the derivative with respect to x of sin time of t. So you know that it becomes dy by dx will be equal to the, you know that derivative of sin t is cos of t. But here the inner function is t, so it becomes dt by dx because this is the inner function. So after this it will become dy by dx will be equal to the cos of t and dt by dx. Our t is sin x, so our t is actually equal to sin x. So now take the derivative of both sides with respect to x, so it becomes dt by dx will be equal to cos x. Now put the value of dt by dx cos x over here, so it becomes cos of x. Now it becomes dy by dx will be equal to the cos of t is actually equal to sin x, so it becomes cos time of sin x and cos of x. We can also find the derivative directly. You know that the derivative of sin is cos x, so it becomes cos time of sin x, and also take the derivative of inner function sin x, it becomes cos of x. So this is the derivative by direct method. Now move toward part number B. Part number D. It tells that a function is given y is equal to sin x and cos x. You know that sin 2x is actually equal to 2 sin x cos x, but over here we are need with the sin x and cos x, so divide both sides with 2. We are left with sin 2x divided by 2 equal to sin x cos x. So put the value of sin x cos x from over here. So it becomes y is equal to sin x cos x is sin 2x divided by 2. So sin 2x divided by 2. Now taking the derivative of both sides with respect to x, so it becomes dy by dx will be equal to 1 over 2 is a constant, so take it outside. So 1 over 2 and derivative of the inner function which is sin 2x. So it becomes dy by dx will be equal to 1 over 2. You know that derivative of sin x is cos x. Sin x is a cos x. But over here we have sin 2x. So replace x with 2x will become sin 2x will be equal to cos of 2x. So derivative of cos 2x will be actually equal to cos of 2x. Also take the derivative of this inner function 2x. So its derivative is just 2. Cancel out 2 with 2. So we are left with dy by dx is actually equal to cos of 2x. So this is the required derivative. Now move toward part number B. It tells that a function is given y is equal to sin x divided by cos x. Find the derivative of this function. So it becomes y is equal to, you know that sin x divided by cos x is actually equal to the tangent x. So taking the derivative of both sides, so it becomes dy by dx. So d by dx of our tangent x. So it becomes dy by dx will be equal to the derivative of tangent x is secant square x. So this is the required derivative for the part number E. Now move to the last part of today's lecture and the last part of question number 1. Question number 1, it is a little bit difficult. Now we can write it just like this: y is equal to sin into pi x square. This is the power. This cube is the power. So we can take this power and the whole sin pi x square. So it becomes sin pi x square. This is on the whole. So it becomes sin pi x square power 3. Now using the generalized power rule of differentiation, it becomes dy by dx. So taking the derivative of this side. So according to the generalized power rule, 3 will come to the front and we will subtract 1 in the power. So it becomes sin pi x square and subtract 1 in the power, so it becomes 3 minus 1. Also take the derivative of this inner function. Derivative of sin is cos x. So here it becomes cos of, here the function is pi x square, so it becomes cos of pi x square. Also take the derivative of this inner function, so d by dx of pi x square. So after simplification it becomes 3 times of sine, it becomes sine square pi x square. Sine square pi x square cos of pi x square is the function, and it becomes a derivative. Let's suppose this pi is a constant, so take it outside, so it becomes pi, and the derivative of x square is actually 2x. So after simplification it becomes a 3 multiplied 2, you know that it gives us a value 6. And after this it becomes x pi, so 6 pi x and 6 pi x, and we are left with sine square pi x square, and after this we are left with just a cos of pi x square. So this is the required derivative, and it is a very important part of the question number 1. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.